Hello, everyone. My name is Hanan Youssef, and I'm a product manager on Google Compute Engine. Today, I will be sharing with you an overview of our virtual machine offerings and how they can help you run your applications effectively, efficiently, and seamlessly on Google Cloud. I hope that after this session, you'll be able to identify the different options that are available to you on Google Cloud, and that you'll be able to leverage them to run all your workloads on GCP. Let's get started. I wanted to start with a quick statement from Robert Inslin, our head of sales. This statement really summarizes one of our main goals for Google Cloud. We believe that your cloud experience should be easy, simple, and pleasant. The best infrastructure experience is the one that shouldn't require extensive research and analysis before each step. Thus, we aim to be the easiest cloud for the enterprise. And Google Compute Engine is no exception. With that in mind, we'll be taking you through the different ways that we're making our VM offerings simple and seamless for you. At its core, Compute Engine lets you easily create, provision, and run virtual machines on Google's infrastructure. You can create a VM, choose between predefined or pre-configured machine types, or create your own custom machine shapes. You can also leverage our recommendations platform, and you can leave a lot of the operational overhead to us with capabilities such as live migration. You can also automatically save money with sustained use discounts and even enjoy deeper savings when you sign up for committed use discounts. Our focus today will be on the first two pillars of this experience, the ones that are under VM types on this chart. So why is this important? It's important simply because you will see that Compute Engine is foundational to almost everything you do in the cloud. It's foundational to the applications you want to run, to the success of your digital transformation, as well as the modernization of your data center and your cloud operations. And because of that, we believe that your infrastructure matters. This makes it important for us to make sure that Compute Engine is the right decision for your business when it comes to providing the right resources in a comprehensive and flexible way that accelerates your innovation. Compute Engine provides you with the right business decisions to deliver the right resources to your teams with simple, transparent, and fair pricing. The tools to optimize cloud spend and pay for what you use, and nothing more. Also, the reliability and security you need to run your mission-critical applications. Compute Engine also tries to offer you everything that you need. Everything that you need to digitize your business so that you can choose your resources based on the business requirements with the flexibility to adapt as your workload changes. You can get access to a variety of predefined and customizable VM families, coupled with flexible consumption models. You can configure your machine types for best fit and optimal performance. Right sizing helps you get the best balance for performance and pricing. And the wide variety of VM families help you get the tailored support for your diverse computing needs. Our VMs are designed with all that in mind. They are designed for real-world scenarios so that you can run the workloads you want in Google Cloud and take advantage of an optimized computing infrastructure that provides you with the right capabilities for all your application needs and helps you accelerate your cloud transformation. This can help you get your scientists in front of innovation and your data analysts in front of insights and your mission-critical applications in front of your workforce. We do that by offering virtual machine types that fit the different types of workloads you might be running. Across our offering, we focus on three key pillars that you will see me covering today. The first one is that our virtual machines will always offer you leading price performance to ensure that you are running your applications effectively and efficiently, and that you are seeing improvements year over year. We do that by leveraging innovations across CPU vendors, and also by leveraging unique Google technologies that we've used internally for years to run our own infrastructure. We also realize that your workloads are not equal. Some of them optimize for high CPU performance, while others focus on high-end memory configurations for business-critical databases. You will see that our offerings are optimized for these different requirements, and they prioritize the needs of the different applications. The third pillar is that we know that you don't run on just a virtual machine. It's all about the end-to-end experience and the end-to-end capabilities across networking, storage, and compute, and other capabilities that make up your infrastructure experience. And because of that, the offerings we'll be discussing today really cover the spectrum and make sure that you can get all the capabilities that you need. Our VM families, our virtual machine types, come in several shapes, from general purpose to workload optimized. Starting on this chart, from the left, you'll see that our general purpose VMs are simple, flexible, and the best fit for the majority of your workloads. E2 are our general purpose VMs that allow you to benefit from deep savings, up to 30% of our general purpose pricing. This family of VMs is great for customers who do not have application dependencies on a specific CPU architecture. You simply pick the amount of vCPU and memory that you want and we'll provision it for you. We proactively adjust the capacity for the entire fleet to optimize utilization, and that means that we give you whichever processor family is available. Based on that, we enable you to save a lot by leveraging E2 VMs. The second VM type that we will talk about today is the family of general purpose VMs N2 and N2D. These are our most flexible VM types. They offer leading performance per dollar, the latest CPU architectures from both Intel and AMD, and a wide range of shapes and capabilities. You can simply attach a lot of other preferences to these VMs. N2 and N2D are the next generation following N1 VMs, offering a significant performance jump. Now let's move to the workload optimized VMs. Compute optimized VMs are the best fit VM type for compute intensive workloads, including AAA gaming, electronic design automation, and high performance computing. They are powered by high frequency Intel scalable CPUs and offer approximately 40% higher performance compared to other GCE VMs. Next on this list are our memory optimized VMs. They are the best fit for memory-intensive workloads, including in-memory databases like SAP HANA, in-memory analytics, and in-memory cache. Memory-optimized VMs offer the highest memory configuration available on GCP, and they can be configured with up to 12 terabytes of memory today. Finally, we're working on a new GPU-optimized VM type, A2, that will offer the latest GPUs available and will be available later this year. Now let's start going into these different VM families and let's understand how they fit your different application requirements. We'll start with general purpose VMs, and we'll start with E2. For general purpose workloads that prioritize cost savings, E2 VMs offer up to 31% savings compared to N1 VMs on both list and commitments pricing. This makes them the lowest total cost of ownership, or TCO, offering available in Google Cloud. They are a great choice for web servers, small to medium databases, dev and test environments, and many applications that don't have strict performance requirements. They offer a comparable performance baseline to the current N1 VMs for those of you who have been using them. E2 VMs are available with up to 16 vCPUs and 128 gigabytes of memory. And they also support flexible configurations through custom machine types that enable you to right-size your resources. Some constraints you should be aware of is that E2 VMs run on any available CPU in our infrastructure across Intel and AMD. They also run across older and more recent CPU generations. You cannot select your CPU. These VMs do not offer you the ability to attach local storage or GPUs. However, they benefit from dynamic resource management, which is an efficient scheduling mechanism that enables us to give you only the resources you need and leverage live migration to move you to a server host with more resources as your application asks for more. This Google technology brings you a lot of benefits as long as you have a flexible workload that can benefit from these resource constraints. To assess the benefits to your workload, you can look at the potential performance per dollar improvements shown on the slide. We're showing here examples of some benchmarks and how they leverage the E2 cost savings. For example, you can see approximately 30% higher throughput per dollar for web serving workloads. The same benefits are also available when looking at benchmarks that represent app and dev testing. For workloads that could benefit from these improvements, E2 also offers a large list of upcoming features that you can look forward to. We are continuing to expand the capabilities of E2 VMs with new features that include making them generally available in more GCP regions, making them leverage AMD CPUs as well as Intel CPUs in more locations, and also for the first time offering committed use discounts for shared core smaller VMs so that you can even get more economic benefits. And finally, we're continuing to look at new machine types that would expand the available configurations too. Now let's move to N2 and N2D VMs. These VMs are the best fit for a majority of your general purpose workloads, as they prioritize flexibility and offer leading price performance. N2 and N2D VMs are a great fit for your enterprise applications, databases, and many of your web and app serving workloads. They are also our most flexible VM offering. They give you a wide feature set, enabling granular control of your resources and coverage across capabilities that range from sole tenancy to the flexibility to add and remove storage at any point, for example. General purpose N2 and N2D VMs are designed to support a variety of workloads. By offering a perfect balance of compute and memory resources with up to 200 vCPUs and 800 gigabytes of memory. Flexibility is really a core priority and differentiator for this VM family. Our VMs, our virtual machines under N2 and N2D, enable you to right-size your resources, which is a great cost-saving feature. They also enable you to auto-upgrade to new CPU generations as we launch the latest architectures in the market. This means that you can simply choose a minimum CPU platform, and Google will automatically run your VM on the latest CPU generations. You can attach up to 9 terabytes of local storage per node, and you can get the highest networking performance with 32 gigabits per second. These VMs are also being rolled out globally across all of our Google Compute Engine regions. Thinking about the key differences between N2 and N2D VMs, you can see an overview summarized over here. N2 VMs are our general purpose Intel VMs, supporting the latest second-generation scalable processor from Intel with up to 80 vCPUs. They come with approximately 20 to 30 performance improvement, giving you a great price performance benefit over the older generations. N2D are our AMD-based general purpose VMs. They leverage the latest EPYC Rome CPUs, and they come with up to 224 vCPUs per node. They even offer you a lower price point with approximately 13% lower pricing versus comparable VMs. Now let's move to some benchmarks and show you how you can benefit from our latest general purpose VMs. Over here, you can see a wide range of benchmarks showing improvements that range from 25 to 30% for most workload types. You can see that N2 VMs show great improvements when looking at benchmarks like SAP Benchmark DB, for example, which represents high-end databases. And over there, we can see 30% higher SAPs compared to comparable VM types. When we look at benchmarks like Chromium Compile, you can see that you're achieving approximately 25% improvement in build time, a great example of the benefits that you can see with N2 VMs for many of your applications. Now let's look at some benchmarks for N2D. As you can see, there are many benefits that we can see when looking at data management workloads, given that these leverage AMD's higher memory bandwidth and higher persistent throughput, which is available with the larger VM shapes. We've actually seen up to 2x performance improvements for some workloads like video streaming, which are represented here through the stream benchmark. And they show how this higher memory bandwidth can be of great benefit to many of your workloads. So in summary, N2 and N2 VMs offer a wide range of capabilities and also have a rich roadmap as we think about the capabilities that we're bringing soon to these VM types. Features that we're working on range from bare metal instances to higher networking performance with up to 100 gigabits per second. We're also working on bringing you the latest CPU platforms across both Intel and AMD, and you will see those continuing to come very quickly to these instance types. Now that we've covered the general purpose VMs, let's move to some of our workload optimized VM families. We'll start with compute optimized VMs. Performance-sensitive and compute-bound workloads come in many shapes and forms. They might be high-performance interactive web servers, AAA games, high-performance computing across simulations, genomic analysis, or media transcoding. They might also be applications that have very expensive per-core licensing and thus would benefit from higher per-core performance. All of these applications have one thing in common. They would see great advantages from leveraging the higher per-core performance and the fastest CPUs you can give them. And this is where compute-optimized VMs can really supercharge your applications. The compute-optimized VMs are one of our latest additions to the Google Compute Engine virtual machine portfolio. They offer the latest CPUs, Intel scalable processors, Cascade Lake. They offer the highest frequency per core available on Google Compute Engine with up to 3.8 gigahertz. And they offer multiple shapes that go from 4 vCPUs to 60 vCPUs. They also enable you to attach local storage if that's needed by your application and offer you up to 32 gigabits per second networking bandwidth. With capabilities such as NUMA-aware performance and higher performance per thread, as well as higher isolation for latency-sensitive workloads, these VMs can offer you a great boost for many applications. Looking at how this can benefit you, let's look at some of the benchmarks over here. These benchmarks represent both highly interactive applications and higher performance computing workloads. The results are evident. All of them see approximately 40 to 41% performance improvements. This can see over here in the increase in the average queries per second, and also the decrease in the average runtime seen under OpenFOAM. With these benefits in mind, we also wanted to share with you some of the capabilities we're adding to the compute-optimized VMs over the next few months. These include bare metal instances support, as well as an increase in networking performance with 100 gigabits per second coming soon. As we've mentioned for the general purpose VMs, we're also always looking at the latest CPU innovations so that we can always offer you improving price performance as you utilize some of these VM capabilities. The second family under our optimized VM types is memory optimized VMs. Memory optimized VMs are designed for high-end business critical applications, and specifically SAP. They are a great fit for in-memory databases like SAP HANA, in-memory analytics, and in-memory persistent cache. They offer you the highest memory per core available on Google Compute Engine and the lowest price per gig of memory as well. They feature the latest and fastest memory technologies and come in different shapes that range from 1 terabyte of memory per node per VM up to 12 terabytes per node, which is really enough memory to run your most memory-intensive applications. In addition to the shapes and capabilities of these VMs, they are also optimized for flexibility and simplicity. For example, capabilities like live migration helps you minimize downtime even as you run workloads that require 12 terabytes of data in memory. We can take away a lot of the overhead for operating those VMs. They also come with flexible commitments across all the memory optimized shapes so that they can continue to grow with you as your data size grows. A great example of that is illustrated over here when we look at some of the customer case studies for our customers who've been using those VMs. And referencing one of the testimonials we've seen customers with 9 terabytes of SAP data that is growing approximately at 1 terabyte per year. So for them to be able to leverage our flexible commitments and the many sizes we offer simply means that they can maintain support for their data size as it grows on our platform. If you have workloads that would benefit from these memory configurations and would benefit from the memory optimized VMs, you also have a lot of capabilities to look forward to. Some of the capabilities that are coming soon to our memory optimized VMs include higher networking and storage performance, as well as additional SAP certifications, and of course, newer CPU platforms and additional shapes so that you can always right-size your VM to the requirements of your applications and your databases. Now that we've given you a quick overview of all of the VM families and virtual machine capabilities available on GCP, we wanted to leave you with a few statements on how to best get started with these virtual machine types. So for your workloads that would benefit from the memory optimized VMs, we also have a very rich roadmap that you can look forward to. This includes networking and storage performance improvements. We're looking at 100 gig enhanced networking capabilities, as well as new capabilities under extreme storage, extreme persistent disk, that would bring you the highest storage performance for these large VMs. We're also looking at more SAP certifications so that you can run more workloads on these virtual machines. And as always, we're looking at newer CPU platforms, as well as additional shapes so that you can always right-size your VM and leverage only the resources that you truly need, minimizing waste. Now that we've taken you through all of our VM types and families, we wanted to leave you with a quick guide for how to get started with these different VM types and these different VM families. We look at this as a simple 3-step process. For the first step, consider your resource specs. What are the shapes and resources needed by your applications? How sensitive are you to specific CPU architectures? Do you, for example, need to use something like Intel AVX 512 and need to make sure that you're running on CPUs that have this capability? Do you need to qualify every new CPU architecture, or are you more flexible in terms of the underlying hardware? After you've thought about that, we would recommend that you start thinking about price performance. Which of your applications would benefit from higher performance? Which of your applications are highly interactive, where you need the shortest runtime and the best latency, for example? That would be one category of applications that would benefit from our highest performant compute instances, like compute optimized VMs. On the other side, what are the applications that would be a great fit for additional cost savings? Over there, we would recommend that you look at VM types like E2 VMs, for example, that can give you a lot of cost savings. So once you've had a chance to look at your resource specs and look at your pricing and performance priorities, now it's time to think about deployment planning. As you think about your deployment plan, we would recommend you start looking at your capacity requirements and looking at the regions where you want to be running your VMs. You can also find a lot of resources on our Google Compute Engine documentation pages that can guide you through the migration process. This concludes our overview of the Google Compute Engine virtual machine types introduction today. We hope that it was useful and that you have a lot of information to get started with. Thank you so much for being with us today. That's all for today.